Anyways, so we have Ochaun Marshall here for session number 4. He's a developer and security consultant for Secure Ideas. Ochaun is an application security consultant. In his roles at SecureEnds, he works on ongoing development projects, utilizing Amazon Web Services, and breaks other people's web applications. When he is not swallowing gallons of the DevOps Kool-Aid, he can be found blasting J. Cole while hacking, blogging, and coding. He covers everything he does with the signature phrase, I code, I teach, I hack. So without further ado, Ochaun Marshall.
Thank you for that lovely introduction. All right, a shock to the system. Static analysis for real AppSec. So this is the part of the talk where I am supposed to spend like an hour on this slide after the speaker already introduced me. But no, what I talk about in this talk is actually comes from a place of trying to eat my own dog food. And what I mean is that whatever madness that I prescribe as an application security consultant to the client is things that I actually have to implement next week when I'm actually on a sprint cycle. So between doing each of those things, I hope by spreading the message adds that teaching element as well. We're going to cover 3 things: tools, techniques, people. This is not the traditional use of TTP, and that is on purpose because the human element at least deserves 33% of the talk and is where the security starts. It's where the security happens and where the security ends. So you ignore the people element to your peril. However, I do realize that this is a support group for security nerds like myself, so I have to do tools and techniques, and I have to do 2 demos with that. All right, static analysis. This is the definition for those who are uninitiated. The whole point here is that we're trying to examine the source code without any execution. We're not running it. This is not a full-on pen test. However, tools and insights that we get from static analysis can feed into a pen test. And in fact, you can pop CVEs by doing a full white box assessment with the stack, one analyst going through static analysis, and then another consultant working on the actual pen test portion. But there are many things that can lie to you. Remember this whole recurring theme of trust but verify, but the code cannot. Also, this is new because although some of you are like, we've been at this, Ochaun. We've been at this. It's a whole bunch of alerts. We got to sift through them and all of that. Here's the difference. Now we've got infrastructure as code. You know all that inventory that we as security professionals have been trying to get people to do for ages? They have it now. You don't, mind blown. This is awesome. And it's parsable. It's not in a spreadsheet. Screw your spreadsheet, okay? It's JSON, YAML, it's machine readable. You've got an inventory of all the infrastructure along with the configurations listed in there. And so with all of these pieces, you can sort of rewrite the story of what a traditional static analysis engagement is. And so the traditional story is, we come in our support group, we commiserate with internal security team and the CISO. We gotta plot against the devs, right? We don't do that, but that's the culture on the other side. And so we do our best work. We dive in. We make some recommendations. However, That produces a PDF that then has to be transliterated from the security people into actual way that the development team can understand. There is a better way. And I'm hoping by the end of the talk that you have the breadcrumbs to lead to how we can change that story. Now we're going on to tools. Tool talk, tool talk, tool talk. Pick a scanner, any scanner. The first instinct may be, all right, static analysis. We're going to grab every tool on the market. Let's see what our budget, blow it up. I don't know about you, but some people's security budget have been slashed because of COVID, right? I can't raise my hand because I work for a security company, but some of you who work in internal teams, COVID has done a number on the security budget. So when we're trying to return to normalcy, it would be really nice if we could spin up things that are free, right? That don't, and free as in free, but don't cost me like weeks and weeks to configure and provision and get it actually working. So here we need to build tooling around need. But first, before we even reach at the tools, you got to ask some basic questions. Do you know what language some of these applications you're trying to protect are written in? Are you aware of the tech stack that surrounds it? Also, it's essential to keep the tooling at a minimum. Reduce it. Minimalism is wonderful, wonderful thing. It's a noise reduction so that when the alarms go off, they're focused on the things that are actual real issues. If you've got devs having to go through dozens upon dozens upon dozens of false alarms, then they sort of numb out. And if there are a whole bunch of alarms, someone could be wrong. It could be the dev team. It could be the way that the tool is configured. So the stack analysis is not the cure-all, of course, but it is a good conversation starter. Now, I'm going to say something. Manual dependency checking is an absolute waste of your time and money. Let me put the numbers behind that. As a security consultant, if I'm doing a pen test for you, that's $300 an hour. That price is on our website. It's public. We think we're competitive in this market, but that's the price. And we normally take a week for a full-on test for a web app. If that pen test is the first time you figure out you're running things like jQuery 1.0 or 2.x, and those libraries that have been deprecated for months, if not years, then it's a waste of your time and money. Because you could have detected that for free. We will write it on the report. Don't get me wrong. We will, because depending on how far you're behind, the whole patch your systems, depending on how far you're behind, that does increase risk. It harms your security posture, as it will. But it should not be the first time we have that conversation. And so if you're, especially since I'm a node developer, I'll give you a node developer solution, especially if you're a node developer. If you're not using Yarn Audit or NPM Audit, what are you doing? Now, we go into the demo. Brief demo is to cover the workflow from a security practitioner's point of view. So if you're a consultant on a job, or you're maybe an AppSec engineer, or internal on the offensive side, and or even an architect, or hopefully an architect or a dev running a static analysis, you would want you don't want to waste time like provisioning the tools. So you'll stand up a VM, and this time we use internally we use Vagrant. Kudos to my coworker, Alex Rodriguez, who definitely pushed this project along and showed me how to work some things in Ansible. So here is, and of course, it's going to be pre-recorded. Don't be disappointed. Don't be disappointed, because if I've timed it, It may take 7 minutes for me to do. That's really fast. However, 7 minutes behind the podium is agony. So we're just going to jump back and we're going to fast forward the bits where I can't type. Of course, it's on the other screen. And just because it's recorded does not mean the demo gods will not screw me over. Are you kidding me? All right. Behold the man behind the curtain. All right. And let's make this as big as humanly possible and skip my notes. So it's available publicly at Stack Analysis TTP repo. Just clone the repository and we're going to start in with a simple CD into the directory. Now this is, again, parts where I'm trying to forget the type. We're going to vim into the, we're going to just vim an overcomplicated text editor just to hop into the Vagrant file and make some modifications. One thing that you will have to do for your machine is point it to which folder you want to share between the Vagrant box and the host. So zoom past, fast forward, and right here, I've got a folder demo where I've cloned some vulnerable code from GitHub. A very hard, very time-consuming and difficult thing to do, most likely. And just, we're going to be running SonarQube, which is one of the tools that can come provisioned with this Vagrant box. So, Vagrant up, and we spin and we fast forward a bit just to spin up through the provisioning. And all this is automating a setup with a VM. So instead of downloading the ISO, getting it in VirtualBox, trying to provision through the settings, trying to get your networking stack to work, this stuff is automated. All of that stuff is automated because you shouldn't be wasting time with your setup. Now, there are multiple tools that are pre-provisioned. Here, it will be SI- like Bandit, MobSF, all of those other tools that were in the previous slide. In this case, we're doing a provision with SonarQube. And to catch up on time, fast forward a bit. And with the provisioning, we're done. So we're going to create, and here we're going to just run the script to create Ansible playbook to create that instance where we'll be running SonarQube. I'm trying, those last two lines are going to be critical. Those last two lines I'm trying to get at. Anyway, click and drag, sign in, of course, whatever password. This is running locally, but sure. And then we just walk through our traditional setting up a SonarQube project. So get the token, this case, we're running it on a Python app that we just found. Copy paste that back into the terminal. And this actually, all the networking is already set up. So I think for SonarQube in general, is either port 8000 or port 9000. It's open to the local host. So from your host machine or whatever web browser, you can access these tools. And the wonderful, beautiful thing about having a VM is that after the engagement, after the exercise, you can actually export, you can actually keep the VM as evidence. So here, we've discovered high-level finding. In this case, this was a plain text password already thrown in. I know it's absolutely tiny, but there it is. So right off the bat, in what seems like minutes, we can spin up and run a VM and just do some analysis. And of course, there are other tools like Bandit for Python. We also do shell check. Why? Well, you're not going to find any security findings out of a tool like ShellTech. But how many of you are familiar with a project that, all right, there's a whole bunch of code, but at the end of the day, like 20% of it is scripted together, is just bash scripts to do things that the developers should have been doing in the first place. I know I have. So let me push it back. Fast forward. So that's the demo. Now we go to detecting with technique. This is really important for continually integrating stack analysis in the software development lifecycle, as we call it. You really need to have engineers look at the code. For your organization is functionally blind without it. Now, if you're dealing with security people, with consultants, we have a list of things in our head when we're doing a web app test. I know I can tell when my networking colleagues are on the test because it's just like, all right, we got to go back into the checklist, check for this, that, and the other. With an engineer, with someone who's writing code and working in software, if you train them appropriately, that flaw is something that pops out. It's a design flaw. That's what it is. It's not a security problem. It is a design flaw. So if you have an internal security team or if you're a consultancy, please only assign the static analysis job to someone who's written production code within the past decade, so their knowledge stays relevant on there. Find someone, if you don't have someone like that on staff, find someone. People who write software are going to find the flaws that general security practitioners can miss. And the devs have to be the ones to do the remediation anyway. If it's any vulnerabilities found is a bug and should go through the pipeline in order to be pushed out. Next is automation. So there's this wonderful XKCD that I love and describes how I'm probably going to be spending the next Saturday night. Do not waste time automating tasks unless you know the steps of what you're doing. You bring the tool in to automate the task once you know rough idea what you're trying to do. CloudFormation, for example, you use something like CloudFormation when you already know what infrastructure you need to set for what infrastructure you're going to set for a project and the configurations for that, the different settings that you would manually go in the console or waste hours waste weeks and months of time trying to script around. So the best way to do automation for security's part is to incorporate some of the static analysis, some of the dependency checking bit into the pipeline. And we also got to think, and this is 4-step methodology, but think of static analysis engagements like a pen test. There's some recon that can be done. Hey, you have the source code in front of you. Is it public when it shouldn't be? Are there keys that have been committed to a public GitHub repo? Are there AWS keys that have been dropped? Simple things for reconnaissance. Most of your time is going to be spent in application mapping for a static analysis engagement, because finding out how this works is about 50% of the job. Vulnerability discovery is instant. Once you scan it, awesome. The exploitation phase, if you're in a white box engagement, that will take more time. But for static analysis, that 4th step is then verifying, all right, is this something? Because I guarantee you, if you get the tool and you see a concatenated SQL string, and you're like, all right, it's SQLi, SQLi, SQLi. However, if you waste hours of time harping that horn, thinking because of what you think and what you've seen the tool, you will miss the fact that in the context of this application, all of the parameters were hard-coded in the code base. So it wasn't like a request. So what seemed like SQLi, what seems like SQL injection, concatenated strings, wasn't, because, hey, every one of those parameters were hard-coded from the configuration files. So it's not like incoming requests from the user can mess with that. But if you don't have that context and if you just go with the alert on the tool, you would be wasting time and energy. So this demo is shorter. And if this doesn't work, that's fine. Because it's only about 18 seconds. So this is from, I'm a developer, so I'm doing this pipeline for an internal app, and the pipeline is stopped. Why? Well, let's dive in and hop into the logs. This is AWS pipeline, and so we're going through the logs, we're digging through. The reason why the pipeline stopped and execution ended is because I don't know about you, but my boss does not let me ship code with high vulnerabilities in the dependency chain. So some of these packages were vulnerable to cross-site scripting. And maybe things are different for your environment. Maybe you have to set up a soft alert and configure it that way. But where I'm from, and some of the clients that I work with are under the same impression. If it's high vulnerabilities in a node package, you would just stop the build on that. And that's something where that needs to be fixed. Now, patching that can be simpler. It can be easy with npm audit fix, and it could also be simple as just upping the version number, so long as they're not breaking changes. And I say that knowing that there are plenty of instances within JavaScript landscape, especially the node landscape, in which breaking changes occur. So, but this is important. This is probably the most important slide. More important than the demo is because I have to show you some success message from this pipeline because I need to actually show that that works. It's not enough to just have the guardrail of all right blocking it. Make sure that it stays functional and it's easy to turn in and fix for patching updates. So when things are doing well, of course the pipelines work smoothly. And we can configure the audit. So you saw a bunch of high, mediums, and lows in that output demo that I did. But you can also just set Yarn audit to only stop on high vulnerabilities. In short, that way, so you're not just raising the alarm flags or throwing an error message in every pipeline. But you also, now that we're bringing it back to CloudFormation templates, now that you've got infrastructure as code as part of the pipeline, part of your pipeline may be standing up additional infrastructure in AWS. So CFLint is your friend. Not only does it alert you to some vulnerabilities, but it's also the friend of as a DevOps person, because CFLint actually gives me some syntax checking on this mile-long configuration file. And if I don't check it at least twice before I push, imagine back in the days where, this is the best thing I can imagine, is back in the days where you had to wait hours upon hours for compiling. It feels like ages of every minute change. If you push it to AWS, all right, it'll take a minute, then it'll crash on whatever issue that you have, and then it will take the next 5 to 6 minutes either rolling back all of the infrastructure or deleting all the resources that change was supposed to make. And so tools like CFLint serves two purposes. It helps us as security practitioner find issues with the infrastructure, and for the devs, it makes their life easier when they have to manually work with CloudFormation templates. There's also another tool called CFNAG, and that tool is also another CLI tool. These are some of the alerts. Things that pop up often are logging and monitoring. Is your infrastructure tied into a CloudWatch or a CloudTrail? This is especially useful for serverless applications where you've got dozens of endpoints and those endpoints have different IAM roles that reach even dozens more services. So if there is no logging done for some simple request made to the backend, then you have no visibility in there, and you cannot tell if you're being attacked or if it's just common usage. And finally, we're bringing it to a vision for you, and this is the people portion of the talk. So when you're starting these engagements, you need to ask some basic questions. What is this app supposed to do? What are the standard use cases? What are the standard use cases? What needs to be protected? If you ask these questions and you're genuinely curious about the answers, you can better inform how you're going to protect it. Because if this is an admin tool, and the only role is admin, and only admins log into it, of course, the base user case is going to be a little more privileged than an e-commerce site. Next thing is to focus on collaboration over compliance. So you will get compliance if you're genuinely collaborative. It's better. It's even better that way. Because I don't bring up static analysis to raise some holy war into your organization. I bring static analysis, and we bring static analysis back into it to begin as a starting point to say, okay, how best can we protect this? How best can we protect this app? And that's another question that's really going to be important. What needs to be protected? And I don't care what kind of shop you have. If it's a DevOps shop or a place where dev and ops are in different teams, that spirit of collaboration can be found both. For some of you who may not understand what's on the screen, that's 2 equal signs in JavaScript. They're both truthy values. So there are more than one ways to be successful, and you don't have to have devs doing all of the infrastructure at the same time. But even if those are distinct camps, as long as they're collaborating together, you get the function. And some of you who are brand new to, can I get the hand count for this is your first BSides? Okay. You did not catch my last talk. I hate the term DevSecOps. It is a buzzword, and it is only a word that people in our support group use, okay? But that is a whole different talk. That is last year. We'll keep moving on. We'll keep moving on. So security, of course, is in the middle, is in this, but it doesn't need its own special highlight spot in the middle, in the center of things, because creating functional code and maintaining availability, which is what ops is, that security is, if you don't detect how security is interwoven in that, you just GTFO at this point, because that is the essential, those are essential parts of it. And now and I'm pretty sure Steve, with the security champions talk at the end, will go more into this. But we need a new type of security champion as we're bringing back into this new theme of, returning to normal, returning into post-plague, and what we need to define what that hero is. And I guarantee you, one of the definitions is not Marvel Universe, DC Comics, saving the blockbuster every summer where we're saving the world. That is not a security champion. Security champions are more like Static Shock. Saturday morning WB cartoon. I loved it growing up. It's not because let's be honest, it's a cosplay option for me right now. And it's not because just because of the background of the young man who's just trying to do the best, who's trying to produce good in the world, who's also lost his mother. Even though that, I didn't know at the time when I was a kid how painfully important that element would resonate with me. Could not have predicted that. The reason why security champions should be more like Static Shock is because the first thing that this young professional, as we will call him, the first thing he does when he comes to power and gets the skill sets is he goes to make his local community better. And I think that sort of resonates with BSidesRDU. Do you agree? Do you agree? So that's where we need to start in that returning to normal. And some of you will look at the slides and it is, seriously, it says wing it, my dude. So now that we're using the tools to actually remove waste, remove clutter, now that we're changing up our technique and how we work with static analysis, not blindly accepting the scanner in order to actually analyze what we have here in applications and associating them with existing security practices like pen tests. And we're also in the spirit of collaboration. What does that look like when it's all pieced together, as the application security program matures. And it looks like this. It looks like not only in the kickoff call do we have the usual, we have the CISO, or we have offensive security engineers, we've got analysts. We also have people from the dev team. In early stages, it's a project manager, an architect that doesn't write code anymore. All his time spent is in meetings. But soon it becomes actual technical decision makers come to the table. And then in the end, and as we go through the engagement, it goes smoothly because we can point out some things. And at the end of the engagement, here's the critical part, you go through all of the findings and verify that there are indeed findings. Then instead of just a PDF report that ages like milk, why not just create the GitHub issues or Jira tickets? Or actually actually have that ingrained into the process to the point where, okay, just like your QA team found this for this quarterly, this major big quarterly or weekly release, all right, these are some security issues that are also added to the backlog that need to be prioritized into the sprint planning phase. And so it's not just one report at the end of it, but it is an actual collaborative journey. And that's the story that's the return to normal story that I'm looking for. And I hope that sort of resonates with you as well. Stack analysis, shock to your system.